Hello, this is Chris Wenker. I'm a GIS epidemiologist at the New Mexico Department of Health. This is a training video for the IBIS community of practice. I'll demonstrate how to use QGIS software to simplify and generalize a shapefile as part of the process of creating a GeoJSON map layer. Shapefiles, like lines and polygons, are geographic features that are made up of vertices that are connected by line segments. Each vertex represents a latitude-longitude coordinate. The relative density of vertices controls the amount of detail and precision in the line or polygon. As more vertex coordinates are stored for each feature, the file sizes also get larger, and larger file sizes can slow down web performance in Leaflet and IBIS. So our goal is to simplify and generalize the features by reducing the number of vertex coordinates, while at the same time preserving the shape of the lines and polygons as much as possible. Here we're looking at an original census file and then 3 more generalized versions. Statewide, we don't see any real difference, or at the county level either. But if we start zooming in on a complex county boundary, we can start to see that maybe the orange version has been simplified too much. Here, the green is the original. The gray was simplified with offsets up to about 100 meters, and the pink with offsets to about 50 meters. There aren't any hard and fast rules for what's acceptable. The degree of simplification depends on the scale and the purpose of the map. The balance is between making a feature very simple and losing too much accuracy. And sometimes it takes a few iterations to find the happy medium. For this demonstration, we'll assume our workflow will use QGIS to modify a shapefile before exporting it to create a GeoJSON. That means in this workflow, we'll do all the preparation work up front. In a different video, we see that even after it's exported, there is actually a way to edit a GeoJSON with QGIS. But in this video, we'll just stick with modifying the original shapefile in QGIS before the export. So here is a raw census shapefile that I downloaded. Now we want to simplify the vertices. We look in the processing menu and open the toolbox. We are looking for a Simplify Geometries tool. I've been using it recently, so it shows up here in my tools. Or we can search for it. But it does live down in vector geometry. Simplify Geometries. The important thing to notice with this tool is the tolerance setting. This is the distance along a polygon perimeter in which multiple coordinate vertices may be reduced to a single vertex. It's measured in the same units as the shapefile's coordinate reference system, so that's a detail that we'll have to determine. We go to our layers properties to find that. Here's the information for this layer. This shapefile, which came from the US Census, is in a geographic coordinate system using the NAD83 datum. And you can search on this EPSG code if you have other projections. The only thing that's important to learn from this right now is that our latitude and longitude map units are being measured in decimal degrees. And that's what we need to use for our tolerance setting. Decimal degrees can be roughly translated to distances like this. 1/10,000th of a decimal degree is about 11 meters. So back to our tool. We input the census file. We define the output location. And now we determine our tolerance. In the past, working with New Mexico files, I've had good results setting the maximum offset to about 25 meters. But with some files, I've had to expand the distance to 250 meters. While testing this particular data set, I found that about 50 meters produces a good compromise, as we saw earlier. So we set the tolerance to 5 10,000ths of a decimal degree, which is about 55 meters. And we run the tool. The tool's done. So if we look in QGIS browser, we can see that the old original census file was about 1.8 megs. And our new simplified file, we're down to about 100 kilobytes. And the 50-meter offset seems like it preserved a decent amount of detail. So now, as we've seen in previous videos, we can edit the attribute table of this file, and we need to add the GeoID and the title fields that we'll need later, and we can delete all the unnecessary census fields, and then we could export this as a GeoJSON for a choropleth layer. When we do that using QGIS, there is an export setting that we can change to create a smaller GeoJSON file size. Here in the Save As dialog, which is what we've seen before in the How to Create a GeoJSON Using QGIS video, we can go down to the coordinate precision and change it from 15 decimal places, which is sort of ridiculous, to 5 or 6. Because we've already simplified the polygons, we have no need to retain such precise coordinates, and it makes for a much smaller file. Finally, I should point out one other consideration. If you're building a set of geographies that are all supposed to nest within each other, let's say you want to have a set of map layers that run from small areas, such as census tracts, to counties, to regions. And all these geographic areas share some common boundaries as you move up the chain. To produce a final set of layers where all the common boundaries are exactly coincidental, you should start with the file of the smallest region you'll be using, such as census tracts. Process those polygons with the tool, as we just discussed, to simplify them. And then once you have an acceptable product, you will want to use the dissolve tool to merge the tracts, for example, into counties by using the field maps. And then merge those counties into the next larger area, and so on. When they're all superimposed, the final set of layers will all share coincident boundaries because they all derive from the simplified version of the first file you processed. So now we've simplified the features and the attribute tables are properly structured, and we've exported a GeoJSON, but we're not done yet. We can still discuss other ways to reduce GeoJSON file sizes by text editing, which is covered in another video. We hope this introductory video about IBIS mapping has been instructive. Please check out the other videos in the IBIS Community of Practice YouTube channel.